So as promised, the idea floated in the last lecture using dictionaries has been turned into a project idea. The idea being, if you review that video and you review the notes for the video, this might be easier than some of the other ones. So what is this supposed to do? It's supposed to open a file and produce a word count like this. It opened, I just copied and pasted, some text into a file from War and Peace. And so the word I appeared in there 5 times, the word if appeared in there 2 times, the word of appeared in there 2 times, the word are and appeared in there 3 times. And then a letter count, right? Counts versus letters, There were 31 A's, there were 33 E's, there were 39 O's, there were 18 R's, and so on. So that's what it's supposed to do. And then I go into a little bit more detail to just give you that. So what is the program supposed to do? Ask you for a file name, and then read the file, and then to process it, it's supposed to, whoops, I got a typo there. In fact, that's pretty poorly written. I'll fix that. The program will process a file, creating a count of how many times each word appears in the file, and also create a count of how many times each letter appears in the file. And we did both of those on Tuesday, actually. But our final notes resulted in either only one or the other, right? We kept kind of flipping between the two, I think. So by hand, strongly consider using a dictionary. You could do this with lists, but it's a lot more work. Dictionaries make it easy. Since you're supposed to make a dictionary both of words and of letters, you might want to use .seek 0 to rewind to the beginning of the file. You're right, you might want to read in all the words, do all the processing with a for loop, and then use .seek 0. As you might guess, .seek means, find a location in your file, and 0 means just go back to the very beginning. Or you could close the file and then open it again. Or if you're feeling really ambitious, you could do all the processing in 1 loop rather than in 2 loops. And when you're printing it out, here's the suggestion for printing it in order, alphabetical order. If you don't use that, if you just use for value in D, right, or for key in D, then it's not going to be in alphabetical order. That would be prettier. Then some bonus point options. You want to earn some bonus credit. Display a bar graph of the letter counts, right? A little bar graph. And then save the printed output from the word and the letter counts, right? So just create a file and save all this stuff so that later on we can open the file and see kind of the same results. All right. Hope that kind of makes sense. If you reviewed the exam, if you reviewed the video, that one might not be too traumatic. It might be easier than writing a hangman program, or especially one of the ones with a longer description like that PyFighter one. If you're working on the PyFighter one and you want a working program to play with, right, to compare yours against, just email me and I'll send you a working one. However, it's written in such a weird, convoluted way that you won't be able to copy my code and get it to work. That's intentional, right? So that way you have to write your own, but you can run it and compare yours against it. Pardon me?
I think compare all of our crashes to a working copy.
Yeah, it's totally mangled. The code is. I spent a considerable amount of time making it impossible to read. It'd get me fired if I turned in code like that, at a company. All right, so what I want to do today is kind of torn halfway between doing more with dictionaries and halfway between doing something more with lists. I want this kind of be the last lecture on the pure procedural Python. Procedural just meaning the program starts at the top and it runs and it loops and it goes to the bottom. And after this, I want to do a user interface, right? I want to build user interfaces, and I want to do classes where you do object-oriented programming. And then I want to do some JavaScript. And so we basically have 1 more month, right? Now we actually have, until, Windows Finals week, something like that. Anyways, so maybe 6 weeks total, 5 weeks total. But That's a lot of topics, maybe 1 week on classes, 1 week on user interfaces, and then 2 or 3 weeks on JavaScript and HTML. So that's my goal. So today will probably be the last day that we just hit the, that we go through and process this, these textbooks. Although I think they talk a little bit about user interfaces. I'm not sure they do. This one certainly talks about classes. I'm almost changing my mind and wanting to jump into classes right dang now. I don't know that we need another lecture on dictionaries. So what is a class? Right, so far our variables have just been pieces of data, right? We have a string, we put a name in it. Or we have, a number, right? We could ask somebody for their name and for their age and for their height and then their weight, and we could print all that out or do some kind of calculation based on that. Well, the idea behind a class is that you can build a piece of data that has all of that in it, right? You could have a patient class where you store that patient's name and their birth date and their, and their height and their weight and stuff like that. And you can pass the data around as a single object, just like our turtle, right? We've been using a turtle class, and we would create a turtle. That turtle had to maintain some information inside himself in order to work. Had to store his X and Y position, had to store what angle he was going at, what color his pen was, how fast he was going, whether he was leaving a line behind or not. So all of that information was stored inside a single variable. Like whenever we did t is equal to turtle.turtle parentheses, it created a variable that had all that information in it. That variable is called an object. And it's created from a class. So what we do is we define a class, and then our object is built from that class, and our program can use it. So, like books, right? If we were going to write a library application or something like that, we're going to turn ourselves into Amazon, then, what book information might we need about books? The author name, the edition, the publication date, how many pages are in the book, the what's it called, the publisher, right? That kind of thing. So all of that information would be useful to track about books. If we were writing a library system or something like that, we might want to put, how many quantity was on hand and how many were checked out and stuff like that, so that we could keep track of all that. And then it'd be nice if we could just create a book, right? B1 is equal to book, like that. And then we could say B1.name, equal to Harry Potter and the whatever, right? And then B1.author, is equal, see, I forgot the book title up here, right? So might want the title. So B1's title could be that, and the author could be J.K. Rowling, or how do we pronounce her name, right? And, the edition, this is a valuable first edition, right? Maybe we'd just make that a number, maybe we'd make it a string, I don't know, right? And then the publisher, B1.publisher is whatever, Doubleday, or I don't know who did that, and the number of pages in it. We had great big books. All these 8-year-old kids were reading huge books. It was kind of neat, and so on. Publication date, I don't know when the first Harry Potter book came out, pub date, equal to 1990, whatever, right? Harry Potter and the whatever. Okay, and then we might want to, what are we going to do? We might want to print that information out. Probably wouldn't just say print B1, right? Because that's not, that function name is already used, right? So we might want to, give it better names like display book or whatever. But these functions could be part of the class, just like when we had a turtle and we did turtle.fd to go forward, right? That function was a part of that object. So, b1 print, like that. It prints the book out. b1.save to file, and we specify a file name to save it to, right? Whatever. And b1.read from file, right? We want to load up some information, you know, from a file. That kind of stuff. So all of these would be functions that are attached, that are part of our book class. So these things can be called fields. They could be called member variables. They've got all sorts of different names based on which language you're using and which textbook you're using. And then things like print and save to file and read to file, right? These are usually called methods. A method is a function that is part of a class. So print and save to file and read from file are all methods, whereas these were variables, sometimes called fields, sometimes called member variables, like that, right? And so the class name would be book. Quite often people say that your class name ought to be a capital letter. So if I was going to do that, right? And if it was stored in a file called book.py, then we might say, you know, B1 is equal to book.book. But this is only necessary. This part is only necessary if the class is defined in another file. Just like turtle was defined in a file called turtle.py. We could go and we could search the Python directories and find turtle.py if we wanted to. Something like that. And take that out. So that would create our object. This would assign some values in our object. And that would use the methods, the functions in the object. So you could say that an object is a collection of data and the methods, parentheses, functions, that act on that data. You could say that a class is the blueprint for an object. So if you combine those definitions, the class is the blueprint for a collection of data. We might say data parentheses variables, right? Variables, yeah, I should have just cut and pasted. And the methods, also known as functions, that act on that data. So why do we say it's a blueprint? Because you could define a class. I have a house. That's my house class. I have a blueprint for building a house. But until I hire, crew to go out and actually make it, I don't have a house, right? I just have a blueprint. The house itself is the object. The blueprint is the class. So example, right? Blueprint for a house is the class. And then the house that gets built is the object, like that. And whenever you hear the term object-oriented programming, that's what it means. To build your program, not with variables and, oh, I'm going to be storing some numbers and strings like that, but instead to be thinking about collections of data. I need to figure out something to do with books, and so I'm going to define what makes up a book and what I might want to do with it, right? Or what defines a patient in our patient record, And then what might we want to do? We might want to be able to print the patient out. We might want to be able to update their information, that kind of stuff. So since we're looking at two different textbooks, why don't we go and look at the one that I've been looking at entire semester rather than How to Think Like a Computer Scientist, which we just introduced recently. Objects. So we've talked about sequential code, just do line after line. We've talked about conditional code, which are your if statements. We've talked about loops, and we've talked about functions. But what we really want to do, I think I may like the other discussion better. I'm going to go to How to Think Like a Computer Scientist. And your book covers this stuff as well. So object-oriented programming had its roots in the 60s, but it really took off in the 1980s when C++ was invented. That became the predominant object-oriented programming language. And then a lot of subsequent languages kind of sprung off from that. Java is kind of a child of C++. It uses very many of the same syntaxes. JavaScript is another one. C# is another one. Python is influenced by it as well. So far we've been writing programs using procedural programming, where we declare our variables, we declare our functions, and then our code, creates some variables and it calls the functions. In object-oriented programming, the focus is on the creation of objects which contain both the data and the functionality together. So a class defines a new data type, right? A book. That could be our class, or a patient record. That's our class. We've been using classes already. A string is a class. A dictionary is a class. A list is a class. Almost everything in Python is actually a class. And turtles are classes. So a mathematical point. You remember taking geometry and you had a point and it had an x-coordinate and a y-coordinate, right? So you could define a class and it had two member variables, x and y. So the class is defined not with the def keyword, but with the word point. Excuse me, the word class. I have no idea what the pass keyword there is supposed to mean. Here it is. The pass statement has no effect. It's only necessary because writing a compound statement must have something in its body. All right. What do you know? I'd forgotten that even existed. Just like if you were going to define a function and you didn't actually want it to do anything, you're going to define f, right? And then you didn't want it to do anything. That would be a syntax error, And so you'd probably put a return there. Well, instead of sticking a return statement in our class, you define the class, and you can put pass if there's not going to be anything in the class. Now, we'll never see that again because we're always going to be having some data or some functions in our class. Now, this is known as a docstring. If you have an advanced Python editor, then when you created a point, you could put your cursor over the point, and then it would display what it was. It would display that string. It's a point class for storing mathematical points. All right, so then the class, okay, remember when I was saying that some texts call them member variables, some texts call them fields? Well, yeah, we got to have a new name. Attributes. I'm going to go and modify my notes to use that word. So, the class is a blueprint for a collection of data, attributes, which are variables, and the methods that act on that data. And that's worth spitting out entirely as, its own point. The member variables of a class are called attributes in Python. I'm probably going to use that term because if you were talking to any Python programmer who'd ever learned another language, they would also know that that is the same thing. That's like the Java term for it and the C++ term for it. So once you created a point, you might be able to do p.x is equal to 3, p.y is equal to 4. Then that point would represent a geometric point where on the x scale it was 3 and on the y-axis it was a 4. And so you have a single object that's got two variables in it. Then later on, if you print p.y, well, since we set it equal to 4, it's going to print 4. And then if we print p.x, right, we set it equal to that. So if you see this syntax, what it means is go to the object p, or go to the object that p refers to, and then get the x variable out of it. Get the value of x. So when you define a class, here's how we would define a class that had the points, values x and y in it. Let's define our own class, except rather than using X and Y, let's make it have name and age, something like that. So I'm going to create a new Python file rather than my notes file here. And this is going to be a person class. The person class is going to track somebody's name and age. Better save this as today's notes. So I can minimize that. Okay, so we use the class word. That's how you define a class. I'm going to call it person because most textbooks, most people recommend that you call your class with uppercase letters to distinguish them from the variables and the function names you create, which are all lowercase letters. And whenever you start tabbing over, you have to write a colon on the line above it, so we still have to have a colon there. A class is not a function, so we don't have to do, anything like that. A class has got functions in it. Okay, so when the object is created, we want to be able to declare the data that the class can contain. And I goofed here. Let me fix that a little bit. So define, these are two underscores, just like on main, right? When we did underscore, underscore name equals underscore, underscore main, two underscores on either side. And we're going to say that self name, I'm just going to default it to the word Joe. And self.age is equal to 32, whatever. We're going to make it, better than this. We're not going to make it default with silly values like that. But just for now, we are. Okay, so Tom, no, since I don't actually have the way to set the name yet. So P1 is equal to person, like that. And then P1's dot name is equal to Sam. And then P1's dot age is equal to 13. Sam's pretty young. Now let's see what happens if we print out P1. I can't say that I expect it to print out anything useful, but let's find out what it does. Let me go remind myself of what lecture we are on. Are we on Q yet? Nope, we're on T. So I'm going to do a file save as and call this lecture T. So this is our class definition. This defines a function, a method within the class. A function that is defined as part of a class is called a method. And again, I'll probably use those terms interchangeably, right? Because it looks like a function definition. It's just a method is a more specialized function, right? Just like you can have a dog, but then you can have a, a schnauzer. And the schnauzer is a more specific version of dog. All right. Wonder if I've got the syntax right or wrong. Let's find out. Alrighty, when I tried to print it out, it just printed this stuff out. Not very useful. Right, when I tried to print out P1, well, it told me something. It told me that what P1 was is a person object. Not real useful. And then it tells us this hexadecimal code. So we don't really care about that. We'd like a way to make this have better data than that. Why don't we add a print function to our person class? Something like this. I'm going to go and add another DEF to my person. It needs to be indented one level. Everything inside the person class is going to be indented one level. Whoopsie. Print. Parentheses self. If you've taken another programming class that was object-oriented programming like C++ or Java, then that self may kind of annoy you. You might want to get in a habit. Might make more sense if you replace the word self with this, THIS, if you've programmed in those languages, but then the people who specialize in Python are going to look at you kind of odd. All right, so what is that going to do? We're going to print what it is, the person, and why don't we say print name equals, or namespace equals, end quote, comma, self.name, and print, quote, age equals, end quote, comma, self.age. Now that's not going to change the way the program works because we did not call this print method. Looks like we did, but no, that's just a built-in print function. If we want to call that method, we have to prefix it with the name of the object. Well, I guess I'm going to add some comments. Create an object from the person class. And then I'm going to say, down here, I deleted that print statement. I'm going to replace it with p1.print, parentheses in parentheses, and I'm going to say call the print function of the p object. Excuse me, p1 object. Hopefully we'll get better output. It won't just be a random hexadecimal stream. All right, and it did. Printed out that it was a person whose name was Sam and their age was 13. I'm going to scroll these comments off so that I can do a little bit more here. And then I'll pause it, make sure everybody here has got it up and running. I'm going to create a second person. P2 is equal to person. P2.name is equal to Sally. And P2.age is equal to 18. She's older. And then under that P1.print, we're going to print P2. P2.print. Like that. And I could copy and paste that comment and stuff like that, but you already get the idea of what it is. Just like I could copy and paste that. Yeah, I hope it works. Yep. It printed out that the person's name was Sally and their age was 18. Why don't we make this look a little bit better up here? Where we have the print, let's do print person, end quote, comma, end equals, quote, space, quote. And after self.name, let's do comma, end, E-N-D, equals, quote, comma, space, end quote. That'll make it look a little bit better in my mind when we print it out, right? It's all on one line. I like that better. So the big idea behind classes is that once you define a class, you can give it to somebody else and they already have a whole bunch of functionality built in, right? You define a book class because you're writing a library program, yeah, or a book, and then you give that to somebody else who's writing a program to manage a bookstore, and they can just reuse that class, right? They can bring that class in and then you know, give them some documentation. And hopefully, you know, it'll do, they can reuse your code without hopefully having to modify it too much, right? So you can build large projects from classes. When we do user interface stuff, when we draw a window and it's got input fields and output fields and windows and close buttons and, you know, scroll bars and stuff like that, everything you see on the screen is an object. And so that means that everything you see on the screen is created from a class. Wow. Well, why would we do that? Well, because otherwise, creating a user interface is so complicated that it would be impossible to just sit down and write your own user interface within a reasonable amount of time. You just have to manage too much. And then if you were going to write it, for Windows, then the code would probably look completely different than it would on Linux or the Mac or something like that. So by creating a user interface class, which we will be using, Python comes with some user interface classes to define windows and buttons and stuff like that, we can build a user interface pretty quickly. Just like the turtle. If I was going to write a program that was going to, draw lines on the screen and be able to go forward and backwards and left and right and change the colors and stuff like that, that would take a heck of a long time. Or that annoying graphics class that we did, in one of our chapters. Yeah. It was pretty cool, though. Drawing the circles and stuff like that was really pretty easy to use. Once you got the right library and once you typed that long program in, the call to actually draw the circles on the screen were just a few lines of code. Whereas that would be pretty hard if you just had to do all that yourself. All right. What would be cooler is if we could do something, don't necessarily type this because I'm not sure I'm going to support it right yet, is P3 is equal to person and then pass in their name, right? Steve, who is 32, right? Like that. That'd be cooler, right? Then rather than having to create, the pieces of data like that, if we could just specify the pieces of data when we create it. We would modify our init function in order to support that. Maybe we ought to do that. It wouldn't be hard. We just have to change this function. Now, this function call here, the call to init, we need to add two parameters to it. One to accept a name and one to accept an age. Well, let's do that. Let's come up here to where it says self there and do comma name, comma age. But that's going to break this code because when we created P2, we didn't pass in a name and we didn't pass in an age. And y'all are probably used to the idea by now that if you call a function but you don't give it the necessary arguments, then it blows up. You have to fill in every argument. But you can get around that by providing default values, right? Name is equal to quote, quote. That's the default value. Whenever we create a person, if we don't specify it like we did with Steve, their name is just going to be empty. And their age is going to be 0. Those are just default values. So now that it says Joe, that's stupid. We're going to say self.name is equal to name and self.age is equal to age. So whatever gets passed in there will be stored in the self.name variable, the member variable, the attribute. Forgot I need to use a Python term for it. And whatever's passed in as that parameter will be stored in the self.age attribute. And if they don't give an age, like they didn't for when creating person P1 or person P2, then age will be set to 0. And if they don't pass in a name, then the name will be set to empty. So let's print out, let's create two objects. We've already got P3 is equal to, and I'm just about to scroll off. I'm going to cut these two print statements and paste them underneath here because I want to keep this stuff on the screen as long as possible. I'm going to create two more people. P3 is equal to person Steve 32, and P4 is equal to person with no values. So it's all going to be default. And then we're going to print P3 and we're going to print P4. And I know that in the back row it's going to be pretty hard for y'all to see this. All this says is print parentheses P3 and print parentheses P4. That's a tongue twister. So the first line ought to say name equals Steve, age is equal to 32, and P4 ought to just not display much. That's very useful. Ooh, I goofed that up completely. What should I have made it as print? I mean, instead of print. Yeah, it should be P3.print and P4.print. My mistake. If I kept this code on the screen long enough, I would have, remembered to do that. So I'm going to make it P3.print, and I'm going to take the stuff out between the parentheses, and P4.print. Take the stuff out between the parentheses. Maybe it'll work. Alrighty. And so Steve, who was 32, and then nobody, who was 0. I don't know if I like that blank right there. Maybe I ought to make it say unknown or some underscores or something like that to show that, you know, we don't even know what it is. I think I'm going to come up here and in my init statement, I'm going to make it say unknown. Or we could make it say John Doe or something, right? Anything. It could be just a bunch of underscores. But that way, when we print it out, it doesn't just have that blank there. If you like the blank there, you know, if you like no data at all as your default value, that's totally cool. What if we only specify one value but not the other? What if I say that person 4 is Stephanie, Steph, but I don't give her an age? Well, when I run her, it's going to say that she's 0 because we passed in a variable to fill in that parameter, the name parameter, but we didn't pass in an argument to fill in that parameter. Now, if you remember enough about functions from this class or other classes, you usually think the number of parameters here, the number of arguments here, have to match the number of parameters up here. But we see 3 parameters for this function, but we only fill in 2. Or sometimes we don't even fill in any. What happens is that the first parameter always gets filled in. We just don't see it being filled in. And it's filled in with the address of the object itself. And so that's what self.name and self.age are able to refer to. So every method you make within a class is going to have as its first parameter self. Then if you want any other parameters, you can list them out, but they're all going to have self.
What is it? What do you mean by self? Is that just the default name for what it's supposed to be?
It references that these things are part of this object.
Okay.
And in other languages, they use the term this. And I like that better, actually, right? If we wanted to, we could do that, because remember, variable names are meaningless. They just mean something to us. I like that syntax, right? So the name of this object is, you know, Joe, and the age of this object. So that's what self means. It's the object itself. It's the address of the object itself.
It just kind of sounded when we were talking about when we were making people.
Yeah, yeah.
Kind of sounds like it has to do with.
I'm making myself. I'm going to go down here and put a Jeff. Right now. That's what it means. Is it means that specific object. It means that this variable is not like a global variable or a variable that's inside of a function or anything like that. It is instead a member of this class. And I really do like the word this better for that purpose. The textbooks show self. The guy who created Python thought that was a better word. Java and C++ use the this keyword. All right, so we've got one class here. Maybe we're going to create another one, like a circle class that has a radius, or a rectangle class that has a width and a height, that kind of thing. Or square class, you know, that has a side length. And we might want to be able to calculate the perimeter of the square, and we might want to be able to get the area of the square. We tend to do a lot of geometry things in here just because they're easy to come up with in my brain. Sorry for the repetition of the concepts. So let's go down here, way underneath everything, and define a new class. Class square, colon. And then we need to define an init method, just like we did up here. But it's got to have those underscores in it. In other languages, call that a constructor. Maybe even the textbooks that we're using in the printed textbook and the online textbook call it a constructor, because it is called when the object is being constructed, just like that. When it's being constructed, well, you know, it's being initialized, so the init method is being called. Let's go do one. Define underscore init underscore parentheses in parentheses, but inside the parentheses we have to put self or some other variable name. You just need to remember to use that throughout it. And so all our square has is a side length or an edge, right? So self.edge is equal to 0. Right, we create a square, it's not going to have it. Well, that's kind of dumb. Maybe we're going to make it have a default of 1. Doesn't matter, that's just our default value. And maybe later on we'll modify our parameters so that we can pass one in. And what do we care about our square? We care about its its area. So define get area, parentheses self. And what's it going to do? The area of a square is the edge times the edge. So return self.edge. And let's do it in 2 steps. Area equals self.edge times self.edge. Or how about just self-edge to the power of 2? And then return area. You'll notice I did not prefix this one with the word self. That's because it's not a member of the class. It's just a variable. We use it and then it gets thrown away. You know. And so under here we can make a square. S1 is equal to square. Parentheses in parentheses. And then S1's dot edge is equal to 10. S2 equals square. S2's dot edge is equal to 20. Now let's get their areas. Area 1 is equal to S1 dot get area. Area 2 is equal to S2 dot get area. And then we can just print them out. And so if I remember my geometry, the area of square 1 is going to be 100 because 10 times 10 is 100, and the area of square 2 is going to be 400 because 20 times 20 is 400. Oh, and it blew up.
We didn't capitalize.
I didn't capitalize it? Okay. Thanks. There we go. Oh, and that was dumb. What did I do wrong there?
You called S2 on S1 instead of area 1.
Right, I just printed out the addresses of the objects, and I wanted to print those variables. So area 1 and then area 2. You know, and we could make it fancy if we wanted to, right? Area 1 equals, you know, in area 1 equals end quote comma, right? And then comma, and area 2 equals end quote comma area 2, like that, just to make it look a little better. All right, so area 1 is 100, area 2 is 400. What I want y'all to add to this is add, I guess I'll put in a comment, a method called getPerim, standing for get perimeter, that returns the perimeter. I'm pretty sure I'm spelling that wrong. Perimeter of the square, which in this case is just equal to 4 times edge. So go ahead and define another method called getPerimeter and just make it return 4 times edge, or 4 times self edge, just to give you that little hint. And so I'm going to give you all a minute to do that, rather than just immediately show you how to do it. After you've written it, after you've actually written it, you'll be able to do something like this. Perimeter 1 is equal to S1 dot get perim. And then you ought to be able to print it out. Print perim 1 equals end quote, comma, param1, like that. Now that's not going to work for me yet because I haven't written my function. Ought to look something like this. def get param self, and then like param equals self.edge times 4. Not times in this case because it's just 4 sides, 1, 2, 3, 4. And then return param, like that. Yeah. I think I did this totally wrong. Why is this going to blow up? When I call s1.getPerimeter, it's going to crash there. Right, I didn't even create s1 yet, so I need to cut that and paste it to below I create the objects. Now it has half a chance of working. Yep. And so since its edge length is 10, then its area is 100, and its perimeter is 10 plus 10 plus 10 plus 10. So that works. I can't quite get it all on one screen anymore. Unless I take out the blank lines. Close. Alright, I hope you have the idea. The idea that we're defining a blueprint. This is a blueprint for a square. The other one was a blueprint for a book. No, for a person. We didn't actually implement a book class. Let's go and look. So for example, a list is a class. Now when we made lists, we just used empty braces. But it's actually a class called list. So when we make a list, that's one way to make it. And then we could append some items to our list, right? Stuff.append, stuff.append. And then we could sort our list. We could print it out. And then there's this fancy, funky syntax. Apparently they have a method inside their list class called getItem. I don't even think I really want to talk about that at this point, but that's what... Nope, I'm not going to talk about it because I'm not quite sure I remember what that means. So let's add a line to our class, or as soon as we run it, go ahead and run it again, and then type in dir s1. And it lists all of the members of that class. Now we sure didn't create most of those members. The only ones we created were init, get area, get perimeter, and edge. I'm sure a lot of other ones. I wonder what size of. I wonder what the size of a square is. And it doesn't mean like the size of geometrically. It means how many bytes of memory it's using. So underscore underscore size of underscore underscore. And this isn't in our program itself. It's in the shell after we run our program. Parentheses in parentheses. Oh, well, what do you know? I thought I saw it defined right here. Oh, I didn't say s1.size of. Come on. S1 dot underscore underscore size of underscore underscore parentheses in parentheses. Our square takes up 32 bytes for whatever reason. How about our person class? Probably takes a bit more. P1 dot underscore underscore size of underscore underscore. Well, it's also 32. What do you know? I would have thought it was bigger because it had more, you know, it had names and stuff like that. And I have no idea what a lot of these methods do, like reduce. or weak reference, or, you know, the only one that I understand at this point is init. Here's a good one though, string. String makes it easy to print the object. Let's see if we can add a string method to our square class. So I'm going to go back to square. I'm going to do def underscore underscore str underscore underscore parentheses self in parentheses colon, and I'm going to return square with edge equals space end quote plus str self dot edge. I'm trying to build a string to return so that if I try to print a square, remember when I made my mistake of calling print square, print s1 rather than doing s1.print? It printed garbage. Hopefully this will look better now. So after I create my square, right here, I'm going to do print s1. See if that does it. And then underneath here, I'm going to do print s2. Alrighty, and so there's our two squares. A square with an edge equals 10 and a square with an edge of 20. Now if we were totally awesome, what I would do is I would make it so that I could just pass it a 10 there and be able to delete that. But I'm going to leave that alone. I don't see any reason to do that right now. We already showed doing that with the other one. We could make another shape that had like two attributes, like a rectangle. Or a block, a 3D block, has a height and a width and a depth, right? Or a pyramid might have an edge length if it's a perfect square pyramid and a, you know, and a height. And a sphere would just have one value, a radius. Now, if it was a drawing program, we might want to make it have points, like X, Y values. Or if it's a 3D drawing program, you might even need an X, Y, Z value for it. And maybe you need some kind of X rotation and Y rotation and Z rotation values on it. And if you've ever played with 3D drawing, then you're probably familiar with those ideas, right? You can plop a square on the screen, a cube on the screen, and then you can rotate it a little bit X and then Y and then Z, you know, so that you can get it to face in any direction. We could put all that information into a block class or a cube class or whatever. Now, actually making it draw, right, that's the trick. It's about time to stop. What is beautiful soup referring to? If I just run this, I'm curious as to what it looks like. Enter what? Yeah, forget it. I don't know what that's doing. All right, so we're going to stop there. I'll make a Dropbox for us. You're not going to have any homework for classes until you get to the sphere class from April 3 lecture. Don't know why it says April 3. It's actually from 11/1, November 1. You might want to jump ahead and do this class, this program right here, right while it's fresh in your brain, right? We've already done a lecture on it. Or you can wait, you know. You just have to reread the online textbook about it. You might, you know, read your physical textbook about it. Watch the lecture again, heaven forbid. Let's see what that homework assignment is. So write a class called sphere. It has a member variable named self.radius. It's got two methods, get area and get volume. Kind of like our get area and get perimeter. It returns the surface area of the sphere, and it returns the volume of the sphere. Google those up, or text me if you can't find the formulas, right? And then have your code create several spheres and print out the surface areas and volumes. honestly, you could probably take the code we did right here and you could write, finish this homework assignment in 15 minutes based on our square class. It's only going to have one variable rather, yeah, just like a square, right? It only had one variable that had edge. Instead, this one's going to have one called radius. All right, time for our Dropbox. Why did I say P? We're on T. I have to fix that. Dadgummit.